Okay, let's get started with trig identities. Now, I want to warn you that these are often extremely frustrating for students as they start learning them. So just stick with it. Keep on trying. Don't give up. It is a skill that is invaluable in your future math courses to be able to do this. Okay? Let's get started. I'm going to start off by reminding you of the previous trig properties that are important that you should already know. There's the quotient properties, the reciprocal properties, and the even-odd identities. Then there's also the Pythagorean identity. And I notice I wrote Pythagorean identities, but I only wrote one identity. It's because this identity can be morphed into all sorts of others. Well, two others to be exact. So let's take a look at that. So if you notice here with our equation, we've got the sine squared plus the cosine squared equals 1. So I'm going to write that one down here. And then I'm going to write down all the things that we can get off of that. Well, we can move that cosine over and we can have sine squared theta is equal to 1 minus cosine squared theta. And we could also say cosine squared theta is equal to 1 minus sine squared theta. And that's all we can really do with that. Now let's see, what else can we do? Well, we can take our equation here, our original identity, sine squared theta plus cosine squared theta equals 1, and we can divide through by sine squared theta on all of them. Remember, if we do it to all of the pieces in the equation, we have not changed the integrity of the equation. So this is going to give us now 1 plus cotan squared theta is equal to cosecant squared theta. And from this identity, we can get two other ways to write it. We could write it as cotan squared theta is equal to cosecant squared theta minus 1. And we can also write it as cosecant squared theta minus cotan squared theta is equal to 1. So those are the other ways we can write that one. And then we're left here with, and let me write down our original identity first. We've divided through by sine, so that only leaves one other thing to divide through by, which is our cosine. So let's just go ahead and do this. Now this is why I suggest that you don't memorize any of this, because it's really easy to generate out the rest of the formulas. So as long as you know that original Pythagorean identity, you don't have to keep these other 6 or so in your head. You can just know that one and be able to create what you need. So this is going to give us tangent squared theta plus 1 equals secant squared theta. And we used this in the last lecture to solve some problems. So that gives us the tan squared theta is equal to the secant squared theta minus 1. And it also gives us secant squared theta minus tan squared theta is equal to 1. Okay, so that is all of the things that we can do with just this one identity, which happens to be probably the most useful identity because it can put these things together. Now, what's going to happen as you progress with trigonometry is you're going to start, when you see a cotan and a cosecant squared together, or you see a tan squared and a secant squared together, or sine squared and cosine squares together, that's going to trigger something in your mind and make you go, oh, is there something I can do here? Okay, so let's get started with actually working some things. Now At the beginning here, I'm going to ask you to do things like simplify completely or verify to show that a statement is true. So our first example here is simplify completely. Now, anytime you're presented with something you need to simplify or verify, and there are multiple trig functions involved, meaning it's not just one trig function or whatever, a lot of times it's a good thing to go back to the sines and cosines, go back to their original definitions. It's kind of a brute force method, just like when you first learned how to graph, when you very first learned how to graph in algebra, you made a little t-chart, right? Little x values, and then you computed it out and found the matching y values, and you made those little points, and then you put the points on the graph, and then you drew the graph, right? And then you developed. You got beyond that. You got to see, oh, that's quadratic, and it's going to be this shape. Oh, that's cubic. It's going to be this shape. Oh, that's linear. It's going to be like this. Oh, let's do the slope-intercept form so we don't have to find all the points. So there's, as we go on, we're going to get more sophisticated in the way that we do this. But no matter what, always keep in your mind that you can always go back to brute force method. You can always go back to turning everything into sines and cosines and seeing if you can't make it work out like that. Okay. So let's take a look at this first guy right here, and it says cotan theta over cosecant theta, and the directions are to simplify it completely. So I'm going to start off with the definitions here, and cotan theta is cosine theta over sine theta, and cosecant is 1 over sine theta. And so now we have two fractions, so we can change flip. So we've got the cosine theta over the sine theta times the sine theta over 1. And these guys are going to cancel out. And this simplifies to just be cosine theta. Kind of get the idea? Okay, so the other thing that we're going to do in this particular section is going to be also verifying identities. So in other words, you're going to show that the statement is true. And sometimes you work on one side and you get it to match the other side, because if they match, then it's true. And sometimes you just have to do something else to get a true statement out of it. One of the tricks that you can use often, and after you've done this a while, you start seeing some patterns, of course. But notice here that we've got cosines and we've got sines. And when we have cosines and sines, we just hope, we just pray that somehow we can wind up with a sine squared plus a cosine squared, so we can get rid of those things and turn it into a 1. All right, so looking at this particular problem, we can notice that what we have is a fraction equal to a fraction. And the one thing we can do when it is a fraction equal to a fraction is cross multiply and see what we got. So here we're going to cross multiply. And so we wind up with cosine squared theta is equal to 1 plus sine theta times 1 minus sine theta. And we already know that that's the difference in two squares, so we don't really have to FOIL that out. We know that that's going to give us 1 minus sine squared theta. And these are equivalent. I just showed you on the last slide there, but you could move that sign over and we could go sine squared theta plus cosine squared theta is equal to 1, and then we can say 1 is equal to 1 because sine squared theta plus cosine squared theta is 1. Now, one other thing I do when I'm verifying identities, and you'll probably see me do it, and I haven't done it yet, but I start putting things like question marks across the equal sign because we're trying to see if those guys are actually equal. That's just something I do for me, and I wanted to mention it before I started doing it without thinking, and then you're like, why is there question marks? Okay, here's another one. We're going to simplify this guy completely. Notice we have sines, we have cosines, and we have cotans. So we're going to have to turn that cotan into sines and cosines and see if there's something that we can do with this. So let's get started here. I get to just write. One other thing about doing identities is they are a paper killer. So be prepared to use lots and lots of paper. Don't cramp yourself. Give yourself lots of places to think. If you make a mistake, cross it out. Don't erase it. Go back, start it over again. That way, if you start making the same mistake, you can go back and go, oh, that way was wrong, and it'll help reinforce it. Just some helpful hints from me here. Okay, so cotan is cosine of u over sine of u minus this cosine of u. All that crap is over this cosine u. Now, at this point, you can do this one of two ways. You can go ahead and clean up that numerator on that right-hand side, and then make these a common denominator. Notice that there's no equal signs here. We can't get rid of anything. We can't do any cross multiplications or anything like that. We're making one big fraction. We can't get rid of any of the pieces. So I'm going to multiply both sides. I'm going to make LCDs, right? Because the LCD here is sine u, cosine u. So this guy I'm going to multiply by cosine u over cosine u. And this guy over here I'm going to multiply by sine u over sine u. Now I'm not going to do really much with it. I'm just going to kind of drag it along with me right now because I can see by this numerator right here that there's going to be a sign that probably will be able to cancel out somewhere. So I'm not going to be too crazy about running this through. So I'm going to write this. I'm going to have cosine u times this one plus sine u over sine u plus, ooh, it's getting messy in here. Now let's put this guy up here on the top together. This is cosine u over 1, so this guy needs to be multiplied by a sine u over a sine u. And this guy just needs to be multiplied by a 1 over 1. So this new piece here, I'm going to write it. I'm going to go ahead and stick our sine u from right here in front. And then let's see what we're left with here. So this is going to be cosine u minus cosine u sine u all over a sine u. Oops, I just realized I messed this up. This is also a cosine u over here because it's top and bottom, right? Oh, that's so messy. Let me just clean that up. I've just made that just a mess. How are you going to tell what I wrote? I just made it a mess. Okay, let me write it better. Sine u, cosine u. And all this is over this sine u, cosine u. Okay, so cool. Let's see, what can we do? Well, looky here. These guys will actually cancel. That's nice. So let's kind of clean this up. I'm going to go ahead and distribute here and see if this is going to work for us. So we got cosine u plus cosine u sine u plus another cosine u minus a cosine u sine u, and all that crap is over one of those denominators, which is sine u cosine u. Now let's see what cancels here. We have a positive cosine u sine u and a negative cosine u sine u, so those cancel. So let's see what we have now. We have 2 cosine u's over a sine u cosine u So let's keep on going here. So we got the cosine u's are going to cancel. And we're left with 2 over sine u. And if we want to simplify this completely, make it look as best as possible, that's going to be 2. 1 over sine is cosecant of u. So that is that mess up there simplified down to this. So that might show you where, ooh, that could be very, very helpful if I was, say, trying to solve an equation and I had 1, 2, 3, 4, 5 variables and I got it down to 1. That's pretty helpful. Okay, so this is some of the reason why trig is just so helpful and important in advanced math, because we can just do so much with it. Let's simplify another one here. Okay, well, when I take a look at this guy, I see that sine squared v minus 1. And anytime I see the difference in squares, I just got to go for it. And looking at that denominator, I noticed that I could probably factor a tan v out. So let's go ahead and see what this will do for us. So the numerator is sine v minus 1 times sine v plus 1 over, and then what can we factor out of the denominator? We can factor a tan v out of the denominator, and that leaves us with a sine v minus 1. Oh, joy! Now the sine v minus 1's cancel, and we're going to be left with sine v plus 1 over tangent v. And that's really as simple as it gets. If we were to put in sines and cosines here, then it just gets nastier. That is as simple as it gets. It is a trig function plus 1 divided by another trig function. So there we got it. Okay, so now let's start establishing or verifying identities, okay? And when you're verifying identities, you can do it multiple ways. You can make the left-hand side meet the right-hand side. You can make the right-hand side meet the left-hand side. You can multiply a whole bunch of stuff and hope that it all comes out to be something that is true. It's just going to depend, and unfortunately you're just going to have to play with it to see and get some experience, because you will never be good at this if you don't struggle and do poorly at it and fail and you can't find it and you get pissed and you rip up your paper and you throw your book around and you're angry. I mean, that's just part of it, okay? You've got to really push yourself through this. All right. And this will be a 2-part lecture, okay? So this particular lecture is going to all be pretty nice, and you might be going, well, I don't know why she made such a big deal out of it. So please heed my words. Okay, here we go. Let's take a look at this one. Now, I see here I have cosecant times tan, and we want to know, is it equal to secant? And I just like to put that question mark, and I hope that you do too. If you don't, that's okay too, but I hope you don't get confused. Okay, that question mark definitely helps. All right, so I'm just going to work with the left-hand side here. And cosecant is 1 over sine theta. And tangent is sine theta over cosine theta. So let's see what happens there. Well, the sine thetas cancel. Awesome. And we're left with 1 over cosine theta, which is secant theta. We did it. Okay, got to show all the logic. Couldn't have just stopped right there. When you're verifying identities, you have to show all the steps. Okay. Let's look at this one. Actually, let me let you do a little you-do here. Now there's one thing you have to be careful of here, and that is the even odd identities. Make sure that you know them, right? And what do we know? We know that the sine of negative theta is equal to negative sine theta. But we know the cosine of negative theta is equal to the cosine of theta, right? So let me give you another 30 seconds here. Now I did kind of set you up here. I did. I'm sorry. I had to. I need to remind you that sine squared of negative theta is this. Cosine squared of negative theta is this. So this is going to be sine of negative theta, cosine of negative theta. All right, and now we're going to apply. So this gives us negative sine theta quantity squared plus, and that just goes away, cosine theta quantity squared equals 1. And remember, we want to know, is this true? Well, negative squared is positive. Sine theta squared is sine squared theta plus cosine theta squared is cosine squared theta, and it does equal 1. That might have seemed trivial, but it was really important for you to really focus in on that thing. I think most of you just pulled that negative out front and then were like, I don't know. So keep it in mind. Okay, let's do another one. All right, let's do this one here. So I'm just going to work over here. So sometimes it gets like a lot, and you just want to work on one side and not work on the other or whatever. You don't have to write the whole thing out here, but when I'm only working on one side, I usually note that. Like I might go left-hand side and just work on the left-hand side. So let's see here. We just saw this, but I'm going to write this again. This is sine of negative theta squared minus cosine of negative theta squared over our negative sine theta minus cosine theta. Right, let's keep on working with that. So we know that that just turns into sine squared theta minus cosine squared theta over, and I'm going to pull a negative out here. Now, if you're paying attention here, you're like, oh, if that was a plus, I would just say it's a 1, but it's not a plus. It's a minus. What do we have? We have the difference in squares. Yes, yes, we do. We have sine theta minus cosine theta times sine theta plus cosine theta all over our negative sine theta plus cosine theta. And now you can see that these guys are going to cancel. Awesome. And we're left with negative, from that negative on the bottom, sine theta minus cosine theta, which is equal to negative sine theta plus cosine theta, which is equal to cosine theta minus sine theta. And we got it. Yay! I actually love these. I hated them as a student, though. Oh my God, I hated it so much. I was so frustrated. So y'all just hang in there. Get too frustrated, shut it, walk away, come back, or go pick another problem, something that looks maybe a little easier, you know. Come back here to the lecture, find one in the lecture, work it. I mean, there's lots of options. Okay, let's look at another one here. Yeah, so can't really work with the right hand side. It's really just one thing. So let's work over here with this left hand side and see what we can do. So I'm going to go for the sines and cosines and see if we can't, like, you know, do something here. So this is 1 plus sine theta over cosine theta over 1 plus cosine theta over sine theta. All right, so we got to put all those together with LCDs and all this. So this is going to be cosine theta over cosine theta. And this one's going to be sine theta over sine theta. Right, and this is 1 over 1, 1 over 1. Okay, so now we get cosine theta plus sine theta all over cosine theta. That's our new numerator, all over our sine theta plus cosine theta, all over a sine theta. Now we get to state change flip, so we have our cosine theta plus sine theta, and you might have already seen what was going to happen, but I am going to show it all, cosine theta, because we're verifying. You need to show all your steps. We have sine theta over sine theta plus cosine theta, and of course addition is commutative, which means 2 plus 3 is the same thing as 3 plus 2, so these guys cancel. And we're left with sine theta over cosine theta, which is equal to tangent theta. Okay, so notice you have to be organized. Your steps need to be understandable. You need to go in an order that can be followed. All right, how about here? Ooh, Now, this looks like a left-hand side situation for me. I'm going to try to just simplify that left-hand side down and hope that we wind up with this. Now, you might recognize this from one of the first problems that we did, because it's very similar. Not exact, but very similar. So let's work here with our left-hand side. Sometimes you have to work the left-hand side and the right-hand side separately and hope that you meet in the middle somewhere. Just saying. Okay, so let's work the left-hand side here. Now I'm going to take advantage of the fact that we can cross multiply. The left-hand side becomes sine squared u. Ooh, let me think about how I want to do this. Give me a second. I mean, this is how I would go after it. Yeah, I'm just going to work that left-hand side, okay? So I just looked at my notes, make sure I wasn't fixing to go down the wrong path there. Okay, so let's go sine u over 1 plus cosine u plus 1 plus cosine u over sine u. So let's get an LCD. Okay, and this side's going to be sine u over sine u. And because we don't have an equation, we can't cross multiply. But this is going to work for us. And this is going to be 1 plus cosine. Okay. So let's see what we wind up here with. We wind up with sine squared u plus, and notice 1 plus cosine u times another 1 plus cosine u is 1 plus cosine u squared. I just want to write it like that just so we can think about it like that. Okay, now I'm going to go ahead and multiply this 1 plus cosine u out because I see I have this sine u also in the numerator, and I'm going to hope that somehow I can get a sine u and a cosine u, a sine squared u and a cosine squared u, and it'll go away and make my problem easier. So let's just multiply that out here. So we have sine u plus 1 plus 2 cosine u plus a cosine squared u all over our denominator here. Okay, now as hoped, we have our sine u and our sine squared u and our cosine squared u, and those come together to equal 1. So now what we're going to have is 1 plus 1 plus 2 cosine u's on top over our sine u times 1 plus cosine u on the bottom. Now let's keep on working on this. I don't know why I put an equal sign there. I'm gonna go up here. So next we're gonna have a 2 plus a 2 cosine u over our sine u times 1 plus cosine u. Now you notice we can factor something out of that numerator. We can pull a 2 out and we'll be left with 1 plus cosine u over our sine u times 1 plus cosine u. And oh, yay, look at that. Those guys go away and we're left with 2 over sine u, which is equal to 2 cosecants of u. Yay! Now you probably didn't see that actually come together, but there it did. So what I'm saying is don't give up while you're working on going, oh, that doesn't look like it's going to do it. Just keep on seeing it to the end. Let's do another one. Actually, let's give this as a you do. I'm going to give you about 2 minutes, okay? Now, what you're going to have to do is I would work with the left-hand side. Work solely on the left-hand side. Turn your cotans and tans into sines and cosines. Put all that together and see what happens, okay? So let's have this as a you do, and we'll have a couple of minutes to work on that. Okay, if you're not quite done, go ahead and pause the video. Don't stop your train of thought. Just pause the video and finish it. Okay? See yourself through. That way you can see a victory when you see it worked out. Okay, let's get started here. So I'm going to work with the left-hand side again for sure. So I'm going to have my sine theta. But then I know I've got cotan, which is cosine theta over sine theta, plus my sine theta over my cosine theta. So I'm just going to work with this one piece right here. So I'm going to just drop my sine theta off here, and we're going to have to do an LCD situation, and this is going to be cosine over cosine, and this is going to be sine over sine. So we're going to wind up with cosine squared theta plus sine squared theta all over our sine theta cosine theta. Okay, so that's great. We know that cosine and sine, that equals 1 when they're squared and added together, and then these two sines cancel. And so we're left with 1 over cosine theta, which is equal to secant theta. Awesome. I hope you were successful. Okay, let's keep on going. Ooh, eek. All right. Well, looks like we're going to have to do something with those secants and those tans, because there is no way for us to break down cosine u over 1 plus sine u. There's no way to break it down any further than that. It is as broke down and as simplified as possible. So let's go ahead and jump on our left-hand side situation here. So secant is 1 over cosine theta minus sine theta over cosine theta. So if we put that together, we get 1 minus sine theta over cosine theta. Well, that is not equal to, which is not equal to cosine u over 1 plus sine u. So we're going to take our 1 minus sine theta over cosine theta and set it equal to the cosine u over 1 plus sine u. And then we're going to cross multiply. Now we can cross multiply because we've set it into an equation. We can cross multiply because it is a fraction. I forgot a fraction. A fraction equal to a fraction. Okay? And that's important. Once you got that, then you can do that. You can do the cross multiply thing. So let's keep on going here. So then that leaves me with 1 minus sine theta times 1 plus sine theta equals to our cosine squared theta. So this gives us 1 minus sine squared theta is equal to cosine squared theta. And all this we know was true, so 1 is equal to sine squared theta plus cosine squared theta. So that's true. So this is a situation where we met in the middle. We don't have to make the left-hand side look just like the right-hand side. We can meet it in the middle where it is a true statement, where it is a true equation, and we're done. Let's take another look here at this one. Let's see here, what can we do? Well, First things first, I'm going to move that cosine squared over, get everything on one side of the equation. So I wind up with 3 sine squared theta plus 3 cosine squared theta is equal to 3. Oh, snap! Well, we can just divide all those by 3 and we get sine squared theta plus cosine squared theta is equal to 1. Done. Awesome. Okay, now we're down to the last one for today, or for this one, because I'm fixing to record the part 2 just in a quick succession here. Now clearly we need to work on simplifying that left hand side to see if we can't make it look like the right hand side, so let's get busy with it. I'm going to suggest that you pause the video right now and challenge yourself, but I'm going to get it done real quick here. So we'll go to the left hand side. Let's work on it here. We've got cosine theta over 1 minus tan theta plus sine theta over 1 minus cotan theta. So I see some business going on here. So this is going to be cosine theta over 1 minus, turning these into sines and cosines. This guy's tangent, this guy's cotangent. We got cosines and sines on top. I'm going to turn them into sines and cosines. So this is going to be sine theta over cosine theta plus this sine theta over 1 minus cosine theta over sine theta. Now let's put that denominator together. You're going to get old hat with this, like so old hat. This is cosine theta minus sine theta over cosine theta. That's that denominator cleaned up. Plus we get a sine theta here on top, nothing to do there, and then I'm going to put the bottoms together, and that's going to become sine theta minus cosine theta all over sine theta. Now the only difference between, well, let's just keep on going. Now, remember that this is over 1 and this is over 1. So I'm going to flip and multiply here. And when I flip and multiply, this becomes cosine squared theta over cosine theta minus sine theta. And then over here, this is going to become plus sine squared theta over sine theta minus cosine theta. Now we're not quite done yet, because notice that these guys are not the same denominators. Their difference is a negative, right? So let's see, what do we want to do here? Here's the other thing that's difficult about these identities. We can solve these a whole bunch of different ways. I mean, a whole bunch of different ways. I think I'm going to factor a negative out and kind of work from there. So I'm going to write down here and factor out a negative out of that right there. So I'm going to wind up with negative cosine squared theta over, and then these guys are going to become sine theta minus cosine theta because we just flipped them around because we took a negative out, plus our sine squared theta over sine theta minus cosine theta. Now these denominators are the same. Yay! So that's going to make us have a sine squared theta minus a cosine squared theta all over our 1 sine theta minus cosine theta. Okay, don't break your algebra. Don't do anything silly like canceling out sines and cosines. You can't do that. That's illegal algebra. Okay, but what we can do is notice that the numerator is the difference in two squares. So we got all that crap over our sine theta minus cosine theta, and oh, I love it when things cancel and it all works out. So now it is equal to our sine theta plus cosine theta. Yay! Okay. Y'all have a good day. Come back for part 2.